Hello everyone. Today in this session we are going to discuss about the RDDs. Okay, as the name says that RDD stands for Resilient Distributed Data Sets. Okay, but just to understand RDDs, we can say that RDDs are like a data structure, or you can say are like a collections which you have already studied. So this is, but these are distributed in nature. That means these are under the partition. The data is your partition. So let me start with RDD stands for Resilient Distributed Data Set. So when I say resilient, I mean to say that this is a fault tolerant. And when I say distributed, it means across the cluster. And data set is your collection of partition data. Okay. So now with this understanding, we can say that RDDs are resilient, and distribution of records. Let's say we have a record and we have created a RDD based on that record. So now that record, once it become an RDD, it become a resilient, and it is a distribution of record which is spread over many partitions. So now we have big data, and then the data is chunked into different parts, and that part is actually a partition and stored in different nodes. Okay, so just for understanding, we can say that this RDD is a core of your Spark. It is just like a kernel of Linux operating system. It's a core of Spark, and it abstract the things. So it do the data abstraction, and data abstraction of, like you can say, partition. That means when I say abstraction of partitioning, that means you don't need to take care of doing the partition. It will be automatically taken care by. And data abstraction of, or you can say, distribution of data also. So how the data is distributed, it is also abstracted from the user. In other term, you can also say that these RDDs are partitioned collection of records. Okay, that you can operate in parallel. Now, as the RDDs are core part of the Spark, it gives complete control, because like you are going to use either Java or Python or Scala. That means this is having objects, and when you have an object, that means you have more control as compared to other data structure which we are going to discuss in the coming session, like data frames or data sets. In this RDDs, you can store anything in any format, right? Now as we discuss that the RDDs are fault tolerant. So it means, what is the meaning of fault tolerant over here? This fault tolerant behaviors is a resilient. That fault tolerant behaviors comes due to RDD lineage graph. Okay, the lineage graph is just like a DAG graph. We will see that later on. Now in this, what happens if the data is lost and you have a graph? That means data is lost in memory, then it can be recreated. That means it can be recreated. Okay, so this is about the high level introduction about the RDDs. So now let's see what is the RDD features. So what are the RDDs features we have? As RDD is a core of the Spark, that means it is in memory. Then another is immutable. When I say immutable, I mean to say that read only. And then this immutable is a very important concept in terms of distributed processing. Because of this immutable behavior, the big data distributed processing is only feasible. Because of this, functional programming is feasible. Okay, another feature is lazy evaluation, and we will discuss this lazy evaluation in just a moment. Okay, another we have discussed, just it is feature is fault tolerant. Another is persistent. You save the data in the RDDs for timing. Okay, so this is persistent. Next, you can say it is partitioned. Another feature is partition. Another is parallel, as we have discussed in this section. You can do the operation in parallel. You can say this is a cached or cacheable. RDD is typed, and it follows the principle of data locality. And it is having a DAG. DAG stands for Directed Acyclic Graph Scheduler. So it is having a graph scheduler, DAG scheduler. Okay, these are the features of RDDs. Now, I think this is simple. I'm just moving forward. Let's talk about the concept called lazy evaluation. So what is a lazy evaluation? Now in Spark, or in, you can say, in RDD, we are going to see two things called transformation in detail in the coming video, and another thing is called actions. Now transformation are the intermediate steps and action is actually the result. So now lazy evaluation means that in this, execution will not start until action is triggered. So action is called or action is triggered, execution will not stop. That means you can have n number of transformation in between for the RDDs, and we will see those things in hands-on part, lab part. So RDDs can have n number, like a filter, you can do that. You can do filter, you can put maps. These are transformation, different maps you can take. Out of, you have, let's say, 5 fields in 5 columns in your data, you can pick only 3. This is another transformation. So in this transformation, what you will do, usually you create another RDD, but the execution is only happen when you call action, like collect, you called count or first. So that is giving you the result. So action is just like a result. So execution will not start until the action is triggered. So now in, out of this operation, these are the operation. So out of this operation, transformation are lazy in nature, right? Because they are not called until action, until called action. So they will not be called until you call the action part. Okay, so what happens when you have a number of transformation in between? What the Spark do? Spark add all the operations, I'm talking about transformation, to the directed acyclic graph in between of computation. For all the computation, it creates a DAG. It will keep on adding the DAG. And when your driver requested, then what will happen? The DAG get executed. Okay, now during this process, the data is not loaded until it is necessary. Now with the help of DAG, it is possible that we can, or with the help of DAG and the lazy evaluation features, allow to recreate the data on failure. Okay, so this is about the lazy evaluation. Now let's see what are the different advantages of lazy evaluation. Now the lazy evaluation, the advantage is, like, it is, you can say lazy evaluation is a optimization technique. Okay, so in this technique, what happens, what it reduces the number of queries, it reduces the number of queries, because you have to execute when the action is called, and you create a different path in the graph, and the best path will be chosen just because of optimization technique. Okay, now I can write like this. Let's say this is transformation, again this is another transformation, another transformation. This is T1, T2, and this is T3. So now this action is being called, let's say. Now what happens in between this step, this step? Okay, so this is your DAG is created for that, and then when you call this action, then the result will be shown to the driver or in the console. Now let's say result is this. When you apply, when you don't apply the lazy evaluation, what will happen? It will go to the result, whatever the result, and then it will call like this again. So this will be a round trip, because every time you are executing. So now just because of that, the advantage is it saves your round trip between what? Between your driver, because result is shown to the driver. So between your driver and your cluster, and this is a part of the cluster. Okay, and which speed up the process. And because of that, it is also reduce the complexity, because we are going to execute in the end and we will choose the best path for that. So because of this lazy evaluation, it increases the manageability. The meaning of manageability is you can organize Spark program into small operations. So I'm just writing small operation, right? So just organize this Spark program into small operations. This is more increasing the manageability part. So this is about the lazy evaluation. Now let's see what are the different limitations of RDD. So RDD's limitation. I'll tell you that a lot of optimization techniques are available in the Spark, like Catalyst Optimizer, Tungsten Execution Engine. But those are available with the data frames and data sets. There are another data structure in the Spark. But in RDD, there is no automatic, you can say, optimization engine, right? The optimization engine is like Catalyst Optimizer, and you can say Tungsten Execution Engine. These are available in data frame and data sets. This is called data frame, another data structure we will see in detail, and these are called data sets. Okay, Another limitation is like, as we are using objects, so there is an overhead of serialization and garbage collector. Now the performance degrade when we don't have enough memory. So slowly, gradually the performance degrade over there. And the main limitation of Rdd is it doesn't support structured data. And for structured data, we have data frames, and the advanced version of data frame is like data sets. Now in this, we don't have no static typing, just like in objects and object-oriented programming and runtime type of safety. You can have any data you can put into the RDDs, and then you can, if you execute, is okay. But on the last moment when you execute, then it will check that data is available or not. Okay, so there is no runtime type of safety there. So this is basic limitations. Now the question arises, when we should use the RDDs. Now question arises, when we should use the RDDs. So when we should use the RDDs, when to use RDDs. And this is very interesting and very important to understand. When we don't have functionality available, or you can't find the functionality, you can't find in your any higher level API. When I say higher level API, means dataset or data frame. Okay, then we need to reuse the RDDs. Example, you can say when you need a very tight control over your physical data movement or data placement across the cluster. So these things you cannot do in data frame dataset. You need some kind of RDDs. Another thing where we need to use RDDs, like just to maintain your legacy code base, which is written in RDD. So already you have written in the code in the RDDs and you want to maintain that, then you have to use RDDs. Another use case, like when we need to do some kind of custom shared variable implementation, then we need to use RDDs, and these custom shared variables are like your broadcast variables, which we are going to discuss toward the end, on the accumulator. Okay, now another point is when we want to have low level transformation or action on our data sets, then we should use RDDs. And just from the limitations, one point is that when the data is unstructured, then we can use RDDs. Unstructured in the sense like media stream, or we have some stream of text, then you can use RDDs. Now if you want to forego the some optimization, or you can say performance benefits available in your data frames and data set. So if you want to escape this optimization performance benefit which are available in data frame and data set, then you can, in that scenario, you can use the RDDs. Or last but not the least, like if you want to manipulate the data, if you want to manipulate your data with your functional programming language, okay, functional programming language constructs, then you can use this. Instead of that, then I'm just writing then domain specific expression. In that scenario, you can use RDDs. So now let's see how we can create an RDD. What are the different ways to create RDDs? The first approach is from your local collection. When I say from local collection, that means we are going to use parallelize collection. Here we have, let's say I'm writing this code in Python. The data is I'm creating a list over there, and then I'm calling the Spark context, which is an implicit variable available in the notebook as well as in the shell. SC, both shell, I'm talking about both shell, parallelize, and I'm calling the data. So that means it will create an RDD, let's say RDD1. So now this way you can have a data set. In this way, data set can be, when we create a parallelize function, when create an RDD, then this data, I'm talking about this data. So this data is now converted, and now it is a parallelize. So now data set can be operated in parallel collection, okay, in your driver program. Now see, the beauty of this code is, for that we have another very important parameter. This parameter is the number of partitions. So now I can write this like sc.parallelize, and I'm putting a data over here, and the number of partition, let's say 5. Now the RDD2 will be there. So now the data will be same, but this is the number of partition. Now this approach is a very basic method. Okay, this is a very basic method of creating RDD, but it is very useful very useful for testing, prototyping, or you can say learning purpose, which we are doing, and even for integrating. Now in this, if you see this part, here we are generating the data programmatically on the fly. So if you want to create data programmatically, then we need to use the parallel function of Spark context, right? So this is the first way of creating. So let me move to the next one. So another way of creating is like from data source. Okay, and this is your external, right? This is your external. The first way is your text file. So how we can do that? sc.text file, and then you put something over here, and RDD will be created like RDD3. The what it can be accepted in this parameter is like it can accept a single file, or it can accept the directory of files, or it can accept wild card list of files, or it can also accept some comma separated list of files, right? So different kind of things can be accepted over here. Now this text.file is actually here. Here you can put some relative or absolute path you can give, or you can say that this text.file only works with new line terminated. Okay, so this is a restriction for that. Now very interesting, another way of using this function like whole text file from external data source, you can put as like a or it can even be whole text files. S is also there, right? This is a function. In whole text file, it will return a pair RDD. So in the coming session, we are going to see that different types of RDD. So pair RDD is like this function will return a paired RDD with having with like you can say key is your and key and value. It will return pair. This is a pair RDD which is having key value. Here key will be the file path and the value will become the file content. Okay. Now you can call this function called sc.whole text files, and you can give the path, and RDD4 will be there. So this is another way of doing this. Now we have another RDD type of RDDs called empty RDDs. This empty RDDs you can call by sc.empty RDD. It means that what you're doing, you just create an RDD with no data. There is no data into that. So RDD with no data. Or you can say that you are creating an empty RDD with no partition. Okay. So this is another type of RDD. Now third way of creating an RDD is from other RDDs. Now for that you need to use a transformation. That means for this we use transformation. So most transformation functions create new RDD from existing RDDs, right? So you can call like RDD1, let's say RDD4 dot map, and then you're calling lambda x colon x plus 5, and it become RDD5. So that means this is your old RDD, this is your old RDD, and this is your new RDD. And just important to understand, this is immutable. That is why new RDD is being created. Okay. So guys, that's all for today's session. Thank you very much for attending this session.